It's Space Radio. This is Paul Sutter, and coming up, we're going to talk about a space octopus, and unfortunately, that is not a joke. And perhaps, if I have time, talking about an interstellar visitor that's outstaying its welcome, and of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about what peer review really means, but first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at Cosine. For the next half hour, your agent to the stars. We've got an exciting show for you today on Space Radio, where we talk about all things. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern in Studio A of WCBE Radio Columbus. This is a special edition broadcasting from the Grandview Theater in Columbus, Ohio. I've got Johnny DiLoretto next to me. He's not going to appear on the show, but he's there. He's going to wave. You can't see that because we're a part of his 24 on 24 marathon fundraising. That is Thursday. By the time you hear this, it will already be over, but you can still contribute by going to WCBE.org. You can also follow along on our live streams on Twitch and YouTube. Check out spaceradioshow.com for the links. We'll take questions that you send there, too. Seriously, folks, I've only prepped 10 minutes of show material tops, so get those calls in. Before I start taking calls, though, I want to share some interesting bits of news that I caught recently. Here's this story. It didn't get a lot of play. But it caught my eye as an object lesson in honestly pretty poor science journalism. This is something that it sticks in my craw. It sticks in my craw when there's a bad science being reported on, even more poorly. But this story has to do with the Cambrian explosion. I don't know if you've ever heard of the Cambrian explosion. It happened about 541 million years ago. Life got started on the Earth a very, very long time ago. Around 3 billion years, plus or minus. But it was just, single-celled organisms not doing much, minding their own business, doing complex things, of course, but nothing much more interesting. And then about 541 million years ago, boom. We see fossil evidence of complex, diverse, multicellular creatures going all around, and it was just crazy. It was a nutsoid time to be alive back in the day, and there's a big question of what's going on, like what instigated this biologically, or is it just a bias? Like now creatures started to have, there was more complex stuff earlier, but just the way we get fossils, there's a gap in our knowledge there, not necessarily in the abundance of life in that era. That's a big question. That's a big biology question, certainly outside of my domain expertise, so I don't want to get into it too much, except there was a recent paper which talked about the Cambrian explosion and framed it in terms of astronomy and astrophysical events, and which is something that I can talk about. And this is a paper by a couple researchers from the University of Oxford in the UK, published in Nature Communications and followed up in later journals very recently, talking about the Cambrian explosion event and just how it seems like kind of an oddball. And they're pushing a particular line of thinking called panspermia. Panspermia is this idea that life did not originate on Earth, but really originated somewhere else and arrived on Earth by hitching a ride on an asteroid or a comet or whatever. And This is a relatively old idea, at least in scientific circles, much older philosophically, of course, but relatively recent scientifically. One of the big proponents was going around in the 40s, 50s, and 60s, an astronomer named Fred Hoyle, who is a fascinating guy who would basically think of every possible crazy idea and push it as hard as he could. And a good chunk of the time he was right. He was wrong a few times, but he was a big believer, big proponent of this panspermia idea. Maybe life was on Earth was seeded from somewhere else. And it's not a very popular idea anymore because one, space is big, and even you can think of the hardiest organisms that can survive the most extreme environments, but then you put them in space for, I don't know, 2 million years, which is what it would take to cross these vast interstellar distances, and it seems a little bit slim. And one of the things that these researchers are pointing to is like, well, look at how special the Cambrian explosion is. Maybe the specialness of the Cambrian explosion is because some DNA material came to Earth and then kick-started evolution. I don't know, like, that's not very convincing. The research paper itself isn't laid out very well, doesn't make its arguments very well, and then it goes off in some weird directions, like, hey, points out that the octopus is relatively strange, has some special features that not any other life on Earth has. Most life evolves by modifying its DNA, but the octopus is able to evolve by modifying its RNA. Again, I'm not an expert here, so I may be speaking beyond my expertise. And they point to that and say, hey, maybe the octopus is special because it came from space? And it's at that point that you're like, come on, guys. You had barely a good idea. That you were barely pushing, like already you were on thin ice. And then you're going to say octopodes, I believe is the plural, is where you're going to go with this? And, okay, like, you lost me. Like there's nothing there. Like, honestly, I know in science we have to always hedge our bets and speak with all the proper modifiers and weasel words but come on, you really expect me to believe, or any other scientist or the general public to believe, the octopodes came from space, and that's your argument, that the octopodes, is so hard to get that plural word out, the octopodes are special, therefore life came from space. But then you can go even further in this line of argument, say, okay, life didn't originate on Earth, it came from somewhere else. Well, where did it originate from? And then the authors of this paper said, well, maybe our universe has been around forever, so there's been a starting point. But we know our universe hasn't been around forever. We know the Big Bang cosmology picture is largely correct. Happy to do an entire episode just on that. If you want to ask about that, feel free. And that's where we are. Like, you got nothing, folks. You just got nothing. Like, you're not moving me. I'm surprised this made it through to even be mentioned in the news. But there it is. But that's the latest and greatest when it comes to space. It's time to have a conversation. Today is a very special recording day because I'm over at the Grandview Theater. We are not taking calls. We just don't have the call-in studio system set up, and I don't have Greg in the booth managing the calls. So I'm only taking questions from the live stream today. And a very interesting question came up from the Space Cadets on YouTube. Yamagishi-san asked about parallel universes, and if there were other universes, would they intersect with us? Could we reach them? Could we touch them? It's fun to imagine alternative universes, other parts of our universe. Can we reach them? Can we talk to them? Can we do anything interesting? Can we observe them? Can we test them? Can we demonstrate the existence of other universes? And fortunately, that's like a gigantic question. Fortunately, Yamagishi-san asked about a very specific subset of the whole broad topic of alternate universes, larger universes, other universes, and that's, we know our universe is expanding. It's getting bigger and bigger every day. Galaxies, on average, are getting further apart from other galaxies. That is the definition of an expanding universe. If there was another, say, Big Bang event next door, doing its thing, with its expanding universe, with its galaxies getting further away from each other, and you can imagine these two bubbles inflating in some four-dimensional hyperspace, that's a little bit hard to imagine, but bear with me. If you can imagine these two bubbles intersecting, and then maybe there are intelligent octopodes floating around in that universe, and we could not shake hands, but hand to tentacle, you know how it goes. Could we have a conversation with them? And is there any path? Is there any path to testing if there are alternative universes in some larger multiverse, grand universe kind of structure? And the answer is yes. The answer is yes. In some models of the very, very early universe, I'm talking about the first second of the universe, very early universe, in some models, there are multiple events that we would identify as Big Bang events, occurring simultaneously, in fact, occurring all the time. And they would each lead to a universe that, like an entire self-contained observable bubble of the universe, containing trillions of galaxies and a very, very large number of stars, and so on and so forth. And effectively, these universes are completely separated away from each other. These universes, it is totally 100% impossible to travel from one universe to another, one bubble universe to another bubble universe, because the universe is expanding faster than the speed of light at its very distant edges. Right now, I believe it's around 2.5 times the speed of light is the maximum observable edge of the universe. That's how far it's receding away from us. You can't travel faster than the speed of light. You can't reach the edge of the universe. You can't travel beyond the edge of the universe. You can't go visit another universe. That's just baked in. But maybe back in the day, things were different. Maybe back in the day, life was a little bit different. Things were closer together. Parts of the universe were closer to each other. And it's possible that different parts of the universe could have intersected with each other. That you have one bubble expanding, and then next door there's another bubble expanding, and they rub up against each other and even temporarily overlap. Now, this moment wouldn't have lasted very long. This epoch where it could have been possible would not have lasted very long, because then eventually the universes themselves would have expanded away from each other as they're continuing to expand. And that expansion away from each other is even faster than the expansion rate, so they're very, very far separated in space, and so they'll never intersect after that. So, but in the early universe, some intersections may have been possible. And we've looked. We've looked for where these universes, bubbles, could have intersected with each other, and we look for them in the cosmic microwave background. The cosmic microwave background, if you don't already know, is probably the most important observation made in cosmology. And I'm not just saying that because, I've done some work to help observe the cosmic microwave background, so I'm very personally attached to it. It is such a critical thing because it gives us a window into the early universe. It is leftover light from when the universe was only 270,000 years old. That's, if you want a metaphor, that's like having a baby picture of you when you were only 7 seconds old. We have light that is 13.8 billion years old, reaching our telescopes right now, giving us a picture of the universe right now, as it was back then. And it could be that either in that epoch or earlier, in the first 270,000 years, that our bubble universe intersected with another bubble universe. What we would see, the observational effect of that, would be circles appearing in the cosmic microwave background. You can imagine if two soap bubbles rub up against each other, you look at where they intersect, they intersect to form a circle. And so we can look in the cosmic microwave background and look for interesting patterns of circles. Do any circle-like features appear in the cosmic microwave background? No. We tried, we looked, there's nothing within our detectable limits seeing a circle in the cosmic microwave background. This doesn't mean that there cannot be other bubble universes, quote unquote, parallel to our own, doing their own thing, being inside their own observable horizons and everything, but it doesn't look like they've intersected with ours. And so that severely constrains the range of possible cosmological models. We can't rule things out, but we can say, well, if there were other bubble universes formed, they have to have a certain limited set of properties, otherwise they would have rubbed up against ours and we would have seen it in the cosmic microwave background. So that's the current state of knowledge. That's the current state of understanding, is that yes, there could be other bubble universes, observable patches. In fact, there most likely are, but they have not intersected with our universe, and they will never intersect with our universe. And that's just it. So that's just one small slice of the multiverse pie. There's many, many different ways to introduce parallel universes, other universes, etc., etc., etc. In that one way, we do know that there's no observational evidence to support it. And that's it. So that's it. Effectively, this is the ultimate lesson of this research. Effectively, our universe is all we got. Our observable bubble is the only observable bubble we're ever going to have access to. It's the only thing we're ever going to see. This is it. This is it. Our set of galaxies, our set of stars and planets, potentially habitable worlds, our set of physics, everything. That is it. That's all we're going to get. So we might as well quit searching for other things, for better universes with different physics. Just be happy with what you got. Learn to love the universe you're with. That is the ultimate lesson from that question. Thank you so much for that fantastic question from the Space Cadets, Yamagishi-san on YouTube. This is Paul Sutter, and this is Space Radio. Remember, this show is brought to you by you. Visit patreon.com/PMSutter to learn how you can support the show. I can't say it enough. It is your donations, it is your contributions that keep this show going, both broadcast on the air and on Twitch and on YouTube and as a podcast. All the venues that this show gets out to, it is because of your generous contributions. Go to patreon.com/PMSutter to learn how you can support the show. Hey guys. Send me another question. Give me another question before I record the next segment. I'm scrolling through the chats on Twitch and YouTube. Give me something juicy, guys. Tommy Johansson. There you go. You got a good one. Welcome back, everyone. I'm Paul Sutter. This is Space Radio, recording a special edition from the Grandview Theater in Columbus, Ohio. This is a Space Cadet only question, or only show, only available to the YouTubers. I'm not taking call-ins right now, but I will next week. And I got a great question from Tommy Johansson asking about global warming and if it's about to be saved by the Maunder minimum, talking about solar cycles. So this is a very, very complex topic. It's also in a very emotionally and politically charged topic about the whole global warming, climate change thing. Here, I'll lay it out for you. There is an overwhelming amount of evidence that the Earth has been warming over the past century or so at an unprecedented rate. Yes, the Earth has been warmer in the past. No, the Earth has not got this warm this quickly in the past, which is what is worrying. And yes, life in general will be fine in a warmer Earth. Our coastal cities and agriculture might suffer in the short term, which is what we really worry about. Now the question always comes up. Of course, the Earth has climate cycles. Of course, the Earth changes its temperature on its own due to a variety of factors, due to changing solar output, due to changing, circulation patterns, the position of the continents, the composition of the atmosphere. There's all this awesome geology, climatology, biology, and astrophysics that all intersect to teach us about the history of the Earth's temperature. And the question is, okay, in the past 100 years or so, when we've noticed this spike, let's say, what's causing it? Would it have happened? This is the big question. Would it have happened if there were no humans around on Earth? The answer is it appears, again, a large amount of evidence suggests that it would not have happened if not for us. That things like solar cycles, that things like positions of continents, these do certainly affect the Earth's temperature, but not at this kind of time scale, not over the course of 100 years. Anything geologic is going to happen much, much slower. We're talking hundreds of thousands, millions of years. The sun does have solar cycles where every 11 years or every 5.5 years it goes from being relatively quiet to relatively bright. This changes the amount of UV radiation, changes the amount of the ozone in the atmosphere, changes the amount of heat reaching the Earth, etc., all that stuff. Well, that's changing, half a decade, every decade, where we're seeing this spike, this temperature trend extend over a century, so we can't blame the sun for that. Nothing else matches up with the right timescale. Everything's either too short or too long or too weak to explain the current warming trend. And we do have an explanation for it, which is increased carbon in the atmosphere trapping heat. That is a very solid physical explanation for what we're seeing. So no, as the sun continues its cycles and goes back into a quiet phase, that's not going to really affect the climate here on Earth. That's not going to affect what's going to happen over the next half a decade, 50 years, 100 years, due to what people are doing to the atmosphere. So again, we can look for all possible explanations for what's happening with the Earth's climate, and we run down the list, and there's only one thing left, and that one thing is a pretty strong smoking gun, and the smoke coming out of the gun is, of course, carbon. I'm not exactly sure where I was going with that metaphor, but I'm going to run with it. There was one little bit of other news that I wanted to get to before the end of the show, and I don't have a lot of time, and that's this asteroid known as 2015 BZ509. Man, I wish we had better names for asteroids, because that does not roll off the tongue. Some researchers at the Côte d'Azur Observatory and the Sao Paulo State University did some analysis of this one particular asteroid. It's in the same orbit as Jupiter, so it's way out there, but it's orbiting in the opposite direction as basically everybody else. There's only very, very few objects that orbit backwards, and so they think maybe it came from somewhere else. Maybe as an interstellar visitor, like if you remember Oumuamua, the famous interstellar interloper from a few months ago. And maybe it got captured and ended up in this retrograde or reverse orbit. There's a lot of news going on about that. Like, hey, turns out we've had an interstellar visitor this whole time. Again, that's research. It's peer-reviewed. It's published. It's fine. It doesn't make it correct. It doesn't make it necessarily correct. In fact, a lot of researchers think this particular analysis is flawed, that they didn't do enough long-term evolution in their dynamical models, that an object like this could arise naturally in our own solar system and end up in a retrograde or reverse orbit without having to come from somewhere else. And that's the game that scientists play. Like, we come up with an idea, we run it through, we take our best guess as to explain this feature of nature, we advance a hypothesis, and that's not the only hypothesis to explain the available data. And we have to weigh the options. We have to weigh the options based on the evidence. So just because one research group says this is what they think, they could be right, but they could also be wrong. Thank you for the great questions from the Space Cadets online. But before we go, it's time for the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And in this show, I wanted to go back to those news stories that I picked out about the space octopus and about the interstellar visitor outstaying its welcome. I picked those on purpose because I wanted to talk about peer review. Usually, especially in the popular media, they'll say, well, hey, this is a controversial idea. It might upset you. It might offend you, but it's been peer-reviewed. It's published in a journal, so it's legit. Scientists are on board, and this is what scientists say. That is a mistake. Peer review is the first pass an idea gets. Peer review, and this is speaking as someone who has had my work peer-reviewed, who has been a peer reviewer. Peer review, you just check to make sure there's nothing outrageously wrong about the actual methods written down in the paper. That when they go from A to B, they didn't make some major mistake. That's what peer review is for. Their premise could be flawed, their conclusions could be flawed. It could be just a total garbage paper, but if they laid out their arguments from A to B and did not make a mistake, it will generally pass peer review. Peer review does not mean the scientific community accepts the results. Peer review does not mean that the results of the paper are correct and to be believed. Peer review is the beginning. It means it's past the very minimum threshold to be published, which means we think it should be shared with the scientific community, and that's a very small personal discussion between the authors of the paper, the referee, and the editor of the journal itself, that they've decided to okay, yeah, we'll go ahead, we'll send this out there. Just because a paper is peer-reviewed does not mean it is correct. Like this space octopus story, the paper passed peer review, okay, it's still wrong. It's still wrong, but just because it's peer-reviewed doesn't make it right. What you have to look at is the long-term relationship between that paper and the rest of the scientific community. Do other researchers continue to follow along the line and build more and more evidence along that conclusion? Or do they pile on and say, this is nonsense, and here's all the evidence that those researchers missed or forgot about or ignored? And that's where it goes. That's where you have to pay attention to. Science is a very, very slow process. Achingly slow. It takes years to decide and evaluate this work. And that's the kind of patience you need. So when you see a story, you see that it's peer-reviewed, take a breath. It doesn't necessarily mean it's correct. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Michalka for being awesome, Johnny DiLera for letting me crash his party at the Grandview Theater, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. You can also catch the YouTube and Twitch live streams. Go to spaceradioshow.com for the links. You can also follow me directly on Twitter, Facebook, and Instagram. My name is @PaulMattSutter, and of course, thanks again, Earthlings, for listening. See you next week, and remember, science is for sharing. End of transmission. We did it. Yep, Constellation Pegasus, you knew it. The space octopus story is flawed. That's one way to put it. You can come back, Johnny. I've got to save my audio file. Say hi to my streamers. Use that microphone. Say hi.
Hello, Space Radio streamers, Space Cadets.
You like that?
Hello, Space Cadets. I heard some interesting stuff. Let me ask you a question real quick. What was the deal with the space octopus? What was that?
The deal with the space
I heard you say space
Yeah, and you didn't listen to the show.
No, I didn't. I have other things.
Look at me. I've got other things to do. I'm Johnny DiLoretto. I've got... no, the main... So some researchers said, hey, octopodes,
Yeah.
which is the plural of octopus.
Is it really?
Mhm.
Octopode.
Octopodes.
Okay.
Octopodes. The octopodes are kind of weird.
Yeah.
They have a slightly different mutation method than other creatures,
Mm-hmm.
and so maybe they came from space.
Interesting. That's really cool.
That's okay.
I know you hate
Yeah, I hate it.
I know you hate that.
Which I said.
Yeah, but I love that. That's cool. Octopodes.
Podes. Octopodes.
Octopodes have 3 hearts.
See how weird they are?
They're
They have
super
3
weird, man.
hearts. Only space creatures have 3 hearts. They have so much love.
Themselves like that.
They have so much love.
You know, like an iguana, it takes a while to work up, the bark color.
The barca.
Like to turn into bark. It takes an iguana some time to do that. But an octopus, bam, bark in like a second.
Except
Or
they don't
sand.
really encounter bark.
They don't encounter bark.
So maybe if they
like
encounter
sand,
bark,
stone,
have you ever held?
coral reef.
Wait, have you ever held an octopus up against a tree? Because maybe the
I bet it
bark,
would do it.
maybe the bark pattern is especially difficult,
Yeah.
and so
Like,
so maybe it has
I
nothing to do
can't
with the
imagine
speed.
it's any more difficult than a coral reef
Sand,
or sand.
just purple.
Yeah.
No, like coral reef is easy. You just go up to the biggest coral
They're really,
and pick its color. Purple.
they're really
You're
awesome.
done.
So, okay, are you done with your show?
I'm done with my show, but I'll hang out
Okay,
for a while if you want. I'm still streaming, by the way.
That's awesome. Keep streaming. Let's just check in with everybody here. Everybody, probably 11 people. I'm Johnny DiLoretto. Yeah, we're
Woo!
live. WCBE 90.5 FM, live here at the Grandview Draft House, Grandview Theater and Draft House in Grandview, on Grandview Avenue, as we said. Very easy to remember. We are in the middle here of a 24-hour live stream, a marathon fundraising event. Dan Michalko, the president of WCBE, is live on 90.5 FM right now on the airwaves from noon today to noon tomorrow. I'm doing the same thing here on Facebook. Probably not as many people listening or watching, but that's okay, because the idea is to drive support for the station through the online community.
I don't know if any of my streamers can hear you, but hey, that's great.
Doesn't matter.
It doesn't matter.
I got streamers.
You got your own
I got
streamers.
my own streamers.
I'm gonna go on to my own YouTube. I'll make my own YouTube.
I'm on my own YouTube, my own Twitch. So, please donate. WCBE needs your help, your support. You can go to WCBE.org and click the red donation button right there. You can click the blue donation button right here on this Facebook page, or you can call 614-365-5711. One quick thing I want to talk to you about
What's up?
before we bring on Doug Dangler, host of Craft.
The Double D.
The Double D. We are doing an interesting challenge, a donation challenge, a geek challenge, Dan calls it. Right now, if anybody goes to our website or calls the number, whoever the first person is, what are we doing?
I'm pointing my camera at you.
Oh, you're pointing the camera at me. How come I don't see myself?
It's delayed.
It's
It's
delayed.
delayed. God,
I got it.
patience. There,
So,
there.
here's the
See?
deal. If you donate right now, whatever means you have at your disposal, phone or through the website or through this Facebook page, you donate $5,000. The Grandview Theater and Draft House will provide you, and I think their theater seats about 300 people. So we'll provide you and 300 of your closest friends and family with a private screening
Wow.
of Solo.
Private screening of Solo.
Private screening of Solo. You can have,
That's huge.
You can have all of your people with you, or you can forego all of your people and enjoy it by yourself with no interruptions. Wow. No,
That's
nobody
hot.
Rustling popcorn. Yeah. Nobody.
A private. How do I get a private screening of Solo?
You donate $5,000 right now
Yes.
to WCB.
At this
The
moment,
first person.
the first person to donate $5,000 to WCBE, that's WCBE.org,
Yeah.
will get a private screening of Solo at the Grandview Theater.
That's right. I got to make sure that it hasn't happened yet.
Because it could be someone could have done it.
Very cool. Let's see. I don't have word yet that it's happened. So will receive from the Grandview Theater and Draft House a private screening of this mega blockbuster Star Wars entry, Solo. Are you excited? Do you care? Do you like this stuff?
Sure.
You don't.
Stream crash for you. All right, guys. Well, I'm going to go. Say goodbye to my streamers.
Goodbye, Space Radio streamers.
Space Cadets. They have a name.
Space Cadets. I like to say Space Cadets.
I'll see you guys next week.